Before we begin, I just want to introduce you to our Year Infrastructure 2020 conference. It's going digital. Join us for the new digital experience live from October 20 to 21st, 2020. Pre-conference starts October 5th, 2020. Before we begin, I just want to run through a housekeeping video with you guys to optimize on the use of ON24.
Hello and welcome to the webinar. This is a public service announcement to optimize your experience on ON24, the webinar platform you see on your screen. Let's get started. At the top left, there is a media player, and videos and footages of presenters presenting will be played here. Below is the Q&A window for any queries you may have during the presentation. In the middle is the slides window. Surveys and polls will be shown here as well. Located at the top right is the speaker bio with a resource list at the bottom to access resources. Next, we will run through the icons located at the bottom of the window. The media player, the slides, Q&A, help, where you can access the event help guide, the resource list, speaker's bio, contact us and refer to a colleague if you would like to, survey to be done at the end of the session, Twitter, Bentley Systems website, certificate to be downloaded at the end of the session for yourself or in group. This webcast is streamed through your computer, so there is no dial-in number for attendees. This means you cannot call into the webinar. Ensure that your computer's audio is audible. Webinars are bandwidth intensive, so closing unnecessary browser tabs and using a hardwired internet connection is recommended. If the slides, video, or any other windows on your ON24 platform does not seem to be working, please refresh your browser. If you do face any other issues, feel free to type it in the Q&A window. Thank you, and I wish you an insightful and fulfilling webinar.
So now I will pass the mic over to Madan to start off the presentation. Madan, over to you.
Okay, thank you, Rick. Can you hear me?
Yes, I can.
Okay, thank you. So greetings, engineers. Before I start my presentation, I would like to have two polls. So please answer these polls to understand the type of audience here, what softwares you are using for designing concrete buildings. You can answer multiple softwares, multiple answers. So I'll give you just 10 more seconds to answer this poll. So please select the softwares that you are using currently for designing concrete buildings. Five more seconds. Okay, so I hope all of you have attended this poll. So let's see the results. As I expected, most of you use StatPro. 77% of you use StatPro. The attendees, let me check the attendees count now, is 190. The registration was nearly 450. Attendance is 190. So this sample is good participation. So 77% of you use StatPro for designing concrete buildings, and 7.6% use RAM structural system, and 30% of you use ETAPS for designing concrete buildings. Okay, the message I want to tell you in this presentation is that StatPro is a general-purpose structural analysis and design software. I'm a user of StatPro for the past 25 years. And during the starting of my career, I used StatPro for designing buildings. But then after I joined Bentley almost 15 years back, I started learning RAM structural system. And then I see the difference between a general purpose program and a special purpose program. RAM structural system is a special purpose program specifically for buildings. It's much more easier, faster, simpler to design a building using RAM structural system compared to StatPro. So that's the message I want to convey here. Using a general purpose software like StatPro to design a building takes more time. Not just more time, it's more complex, I would say. Okay, so let's move on to the next poll. Please specify your role, whether you are a decision maker in your company or managing a team, or you are the end user of the software. I won't be showing the results of this because that doesn't make any sense for attendees. So I'll give you 10 more seconds to answer this poll, and then we'll move on to the presentation for today. 5 more seconds. Okay. Thank you for attending the poll. So the topic for today's presentation is Bentley's structural technology for concrete buildings. The presentation will be approximately 1 hour, and then we have a question and answer session. So the synopsis for today's presentation is, traditionally we see many companies, architectural, engineering, construction companies, use different vendor software products for modeling, analysis, design, detailing, bar bending schedule, quantity, and cost estimation for the concrete building project. The trouble lies in the interoperability of these different vendor products that kills the benefits of BIM. BIM, as many of you know, is a process. It's not a product. In order to make this process successful, smooth interoperability between the above software is important. Bentley's Structural Enterprise Worksuite provides the solution. And that's the synopsis for today's presentation. In many of the organizations, bigger organizations, we see that BIM is getting implemented, but because of this BIM implementation, are you more effective than before or not? Okay, so that is the important thing that we need to find. So one of the important things to make this BIM process successful in the implementation in your organization is to make sure the softwares that you use to complete the project are interoperable. If not, you'll be duplicating the work in the same office, and instead of gaining efficiency, you'll be losing efficiency, leading to BIM failure. Okay, so with that message, I'll move on to the next slide. What is Structural Enterprise Worksuite? It's a special bundle license of around 8 products from STAAD and RAM brands. It includes the advanced StatPro for general purpose structural analysis, design, and detailing. It includes STAAD Foundation Advanced for foundation analysis, design, and detailing. It includes RCDC FE for slab and mat foundation design and detailing. Not the RCDC program. It's RCDC FE. It's a new program. RCDC is now part of StatPro Advanced. RAM structural system for special purpose building, structural analysis and design. And then RAM concept for slab and mat foundation analysis and design, including post-tension. RAM connection for steel connection design and detailing. RAM elements for component design and detailing, like retaining wall design, single member design, steel or concrete, single footing design, etc. It's more like a spreadsheet kind of software. And finally, MicroStrand Advanced, which is again a general purpose structural analysis and design, similar to StatPro, which is widely used in the Australia and New Zealand region. So these 8 softwares are bundled and sold as one single license called Structural Enterprise Worksuite. And what is the meaning of the color code? I put in two softwares, number 4 and 5, RAM structural system and RAM concept in green color and StatPro in yellow color. Meaning for that is, in today's presentation, I'll be covering 4 and 5, RAM structural system and RAM concept, and partly the RCDC portion of StatPro Advanced. For the design and detailing, I'll be using the RCDC, which is a feature of StatPro Advanced, not RCDC FE. Okay, RCDC for beam, column, and foundation design. I use this RCDC from StatPro Advanced. So that is the meaning of this color code. Okay. The other softwares are not going to be covered in today's presentation. I have done that coverage in my other webinars. You can find those in our YouTube Bentley structural YouTube channel. We also have our upcoming seminars, which will address the other softwares. Tomorrow, I'll be covering steel building analysis, design, and detailing using, again, number 4 and number 6, RAM structural system and RAM connection. Okay, so that's for tomorrow. So this slide shows you the big picture. On the left side, you can see the Bentley structural analysis program for special purpose as well as general purpose, for building analysis and design, for general purpose structural analysis design, for slab design, post-tension slab design, foundation design, connection design, slab design. All these are bundled in one license called Structural Enterprise Worksheet. And all these softwares can interoperate to each other using the ISM, which is the abbreviation of Integrated Structural Model. And the other softwares we can see here are competitors stand out to be partners, like Tekla Structural Designer, Revit. No, sorry, not Tekla Structural Designer, it's Tekla Structures. Tekla Structures is a structural detailing program, which many of you may know already, and Revit for building information modeling. And Global is a European software for structural analysis. So all these companies have joined Bentley as partners in co-developing this ISM plugin, which is useful for exchanging the model from these softwares to our Bentley softwares and vice versa. So you can see the arrows are double arrows, having two directions interoperability. And also on the right side, you can see open buildings and pro structures. These are Bentley's BIM program. Open buildings designer is similar to Autodesk Revit, and pro structures is similar to Tekla Structures for detailing. That is Bentley's program. So these programs are not included in Structural Enterprise Worksheet. But the reason I put in here is using this ISM in the middle, using the ISM file interoperability, you can exchange the model from structural analysis software to structural detailing softwares and multidiscipline building information softwares like Revit or Open Building Designer. Okay, sorry for that. Okay, on the top you can see through this ISM, we can even import and export IFC files. We can produce iModels. We can view in mobile devices, etc. Okay, so that's the big picture. The next slide shows you the connected data environment slide of Bentley. This is a digital city or digital country showing all the 100 Bentley softwares for various industries. You can see Bentley has softwares for many projects, many type of industries like water and wastewater treatment plant, buildings, cities, mining plants, roads, construction, campuses like airport campuses, utility networks, rail and transit, wind farms, offshore structures, process plants, power plants, bridges, nuclear plants, communication towers, subsurface utilities, etc. Where is RAM comes in? RAM comes in mainly for the building analysis and design. On the center, you can see, and also buildings, the administrative buildings which we have in campuses like airport, administrative towers, and treatment plants. That's where RAM is used. The remaining all other industries, mostly StatPro is used. So let's go into detail of RAM products overview. What structures are designed using RAM? Office buildings, residential buildings, education buildings, medical campuses, public structures, retail structures. Structural steel, reinforced concrete, post-tension concrete, timber, masonry, foundations. Why use RAM? RAM, as I mentioned, is not a general purpose program. It's a special purpose program custom made for buildings. You cannot use this program for any other structure other than buildings. Comprehensive implementation of building codes, such as live load reduction code, load combination code, seismic code, wind load code, as per all international codes, are implemented in this program. Extensive automation of tedious and time-consuming tasks like skip loading, alternate span loading for live loads on a 3D building, and many other time-consuming tasks are automated here. Basically, RAM suite consists of these four softwares: RAM structural system, RAM concept, RAM connection, RAM elements. RAM structural system is for 3D modeling, analysis, and design of buildings. Could be steel or concrete. Today we'll focus on concrete buildings and tomorrow on steel buildings. RAM concept for concrete slab and mat foundation. We'll see that today. RAM connection for structural steel connection design. We'll see that tomorrow. RAM elements, design toolkits for structural components. We'll see on some other day. So on the screen now you can see a 4-story building. The bottom 2 floors are made of concrete. The top 2 floors are made of steel. And you can see the various RAM modules and RCDC used for analysis and design of this building. Basically, the whole building, including the steel and concrete and composite and non-composite floors and one-way and two-way floor slabs and flat slabs, are modeled in RAM structural system as a whole model. And then you use different modules to design. For example, RAM connection is used to design the steel connections. RAM concept is used to design the flat slab. It could be a post-tension flat slab. RAM structural system itself can be useful for composite beam design. RCDC for beam, column, and foundation design. If the foundation is of mat foundation, we can either use RAM concept or STAT foundation advanced. If it is isolated footing, we can either use RAM structural system itself or RCDC, even for a pile cap and combined footing. RAM elements can also be used for general purpose structural analysis, similar to StatPro. We don't promote it that way to avoid confusion with StatPro users, but its strength lies in its modules. Here you can see a masonry building with timber roof trusses. This can be modeled, analyzed in RAM elements. So who uses RAM? Worldwide, the top companies for high-rise buildings like WSP Group and other companies you can see on the screen use RAM for their projects. Let's see some 2 case studies. The first case study is on Iraq. Here you can see the building. It is not the deflected shape of the building. It is the in-place condition of the building. This is a US $21 million landmark building project by Hamcorp, consisted of 2 towers, each with more than 20 stories. The challenge was executing the vision of the architecture, which resembled falling dominoes, or in an alternative vision, a falling tree grounded by its roots. This project was designed by the consulting engineer Howard Farad Hamad. For such innovative architecture, RAM structural system was critical for the team's analysis using finite element mesh. The project team collaborated by increasing communication across teams within a virtual workspace. The team achieved ROI by clearly defining the potential return from local investment, including reduced overhead, higher employee retention, improved operating efficiencies, and controlled pricing. Would you like to stay in this kind of building? Another case study in near Sydney in Australia. Wood and Grieve engineers designed these water's edge residences. It's a deluxe waterfront apartment development that addresses demand of upcoming upmarket housing. Wood and Grieve engineers provided structural analysis of unique architectural features such as the sophisticated facade and ground foyer. The building's radial layout with non-uniform column arrangement and slab design also required special considerations. RAM structural system provided an efficient means to perform load takedowns and easily accommodate changes in the preliminary analysis phase. And RAM concept allowed the flow design to be imported from RAM structural system to minimize repeat modeling. This improved productivity. So less time was spent building models and more time was spent evaluating scenarios. RAM's interoperability was an important factor in reducing cost. So these are the cases submitted by these two users in our year in infrastructure projects in the past. So we have taken from their presentation with their permission. So coming to today's presentation on concrete modeling, building modeling analysis, design and detailing. There's a large video that I uploaded to demonstrate this. So it takes a few seconds. Oh, yes, it looks like some problem in playing the video. Can some of you respond with pulse check? Are you able to see the video? You can answer. Okay, so looks like you are not able to. Some of you answer yes, some of you answer no. So most of you are saying no. Okay, so what I do is now I'm going to stop this playing this video. Okay, and I'm going to screen share. Okay, sorry for this inconvenience. Hold on for a few minutes. A few seconds, sorry. Okay, hope you are now able to see my screen showing the agenda. Can I do a pulse check? Okay, so I see some of you can able to see the screen. Now I'll play the video and I'll voice over it. Thank you. Okay, so these are the agenda for my next 45 minutes presentation. Suggest a workflow of concrete building, modeling, analysis, design, and detailing. First, we see the workflow, and next we see the modeling, the actual modeling of concrete building, lateral load analysis, concrete gravity analysis, and concrete design, detailing, and estimation, and finally, mat foundation design. Okay, I want to spend more time on modeling because the users here are not fully aware of the RAM structural system features. So first, let's see the first step. That's a workflow. We can do the modeling in either BIM softwares using a Revit or Open Building Designer, or you can do the modeling in RAM structural system itself. You can see the two-way arrow. After we finish the modeling analysis in RAM structural system, we can proceed with the design using RCDC and proceed with RAM concept for slab design and mat foundation design. And see, the interoperability with RCDC is just one way, and the interoperability with RAM concept is two-way. RCDC is otherwise called as STAD Advanced Concrete Design, which is part of STAD Pro Advanced, all part of Structural Enterprise Worksuite license. So the way we model in RAM structural system is exactly the same way we model in a BIM softwares like Revit or Open Building Designer. So I'm going to use for this project using the modeling in RAM structural system, importing and creating grids and gravity and lateral modeling. And after we finish the modeling, we do the lateral loading and analysis as step 3. We create construction stages here before we do the analysis, load combinations, and we do the post-processing. Stage 4, we do the concrete gravity analysis. This is for the gravity members. And stage 5 is the concrete design, detailing, and estimation. And stage 6 is the mat foundation design. So now we'll start the live demo, starting from number 2, that is modeling the building. So I'm going to open up the already completed building before I show the modeling. So let's see this building. It's a 10-story building. The span is 6 meter into 7, so 42 meter in the X direction, and 5 into 5 is 25 meter in the Z direction. In RAM structural system, we call it as X and Y direction in the plan, and vertical is Z, unlike StatPro. And you can see the red color members or lateral members, and some beams you can see blue color and red color. Columns are all red color. I model it everything as lateral columns. Shear walls are also lateral walls. And beams, most of them are lateral, some of them are blue, which is gravity. And I model almost all kind of foundations. Isolated footing, combined footing, pile cap, and mat foundation. I also model the shear wall with openings. Okay, so I hope now you have an understanding about this building, the 10-story fully concrete building. Okay, so now I'm starting a new file, and this is the first screen where you see all the modules of RAM structure system here. All are empty right now. We are going to now start the modeling. I use the RAM modeler and then choose the material. Here I'm going to use the concrete material. And then first thing I'm going to do is specify the layout, the floor layouts. I'm going to use 3 floor layouts, typical one, and a roof for this 10-story building project. And next, I'm going to import a DXF of the grid. So while I import the grid, I select the layer name in the DXF. So before importing the DXF, I have to look at the layer name of the grid by using any CAD program. And then I import only that particular layer. Okay. So you see, I imported the grid from the CAD software, and that includes orthogonal, inclined, and radial grids, so that I don't need to spend time in creating the grids, and then I can start creating the model. Okay, but for this project, I'm going to show you also how to create the grids from the scratch. I'm redoing the layout creation again, the floor layout creation again, and now I'm going to create the grids. Last time I showed you the import, and now I'm going to create the grids manually so that you understand both the process well. So I'm going to create X grids. Yeah, I'm going to label in alphabetical orders in the X direction. 7 grids of 6 meter spacing, and in Y direction, I'm going to label numerically 5 grids of 5 meter spacing. And I'm going to insert a grid and name it as 3.1 with a coordinate of 13 meter in the Y direction. So that is a user-defined grid. Now we can visualize this grid here on the screen. Hope you are able to see the screen with the grids. And now I'm going to model a concrete column. Okay. While modeling this column, I'm specifying this as a lateral column. I just put a fence on the grid to model the column, and then I'm going to delete the column on the user-defined grid. And also some more columns I deleted because I'm going to model shear wall on some of the location. Okay, the central lift core and each 4 sides of the building, I'm going to model shear walls. That's why I'm deleting some columns. Hope everything is going now. All of you can able to see the video well. I'm doing a live sharing of my screen. So one more pulse check to make sure everything is going well. Please respond to this pulse check. Hope all of you are able to see the video. Okay. Some of you already answered that you are able to see the video. Only one of you say no. Rest all say yes. So that one person, it may be a local problem. I would suggest you to rejoin the meeting or watch the recording later. Thank you for responding. Okay, let me continue this. Okay, so now I finished the column modeling. Now I'm going to model the walls. So just using the grid, I can quickly create the walls. I finished the walls on the 4 sides. Now I'm going to model the beams, okay, the lateral beams that are shown in red color. I'm also going to model the gravity beam, which are shown in blue color. The reason why I'm modeling these beams as gravity beams is because one side of the beam is connecting to the wall and one side of the beam is connecting to the column, lateral column. So achieving the rigid connectivity with the wall is going to be difficult. So that's why I'm going to use a simply supported type of connection at the where it connects the wall. That's why I'm using gravity. But it's up to the engineer to decide whether you want to use a lateral all or gravity. Okay, I just want to demonstrate the capability of modeling gravity members and lateral members in RAM structural system, which is a unique feature in RAM structural system, which I like a lot. So what is the meaning of this lateral member and gravity member? Okay, a lateral member takes only the lateral loads. Sorry, it takes both lateral loads and gravity loads, whereas gravity members take only the gravity loads. So this way, the engineer has total control on your distribution of your lateral load into the building. So I finished modeling the shear wall lift core, and then I'm showing you the releases. You can see the gravity members have pin end connections. Okay, I'm going to modify for some of those gravity beams that are connecting to the lateral columns, okay, by using the beam assign beam fixity command. So this way, you can change the connection, the member releases. Okay, so I'm going to skip some of this to save some time. Okay. So next, after modifying all the releases, I'm going to copy this flow to the roof and delete some of the members to create my roof floor layout. Okay. So after I copy that roof floor layout, I think I skipped that copying, which is an important feature. So I'll show that now. Okay. Sorry for that. I'm trying to save time here because we lost some time on sharing the video. Okay. So here, using the copy feature, the story copy flow, I'm copied the typical flow to the roof. And now we are in roof floor layout, which you can see in the top left. And in the roof floor layout, I'm deleting some beams and columns. Okay. This now it shows the slab modeling and the opening modeling in the slab. Okay, for the roof, I deleted the slab. I'm now going to delete the beams and some of the beams and columns. So the end result is going to look like this. And now I'm modeling the slab. Just a few button clicks, your slab modeling is done. Okay, so now we go to the story data to create the story. So now we have 3 floor layouts, typical, typical 1, and roof. Basically, typical and typical 1 are the same. So before going to the story data, I'm now going to give the column and beam properties. So for column, I have 3 types of columns: 1 meter by 1 meter, 750 mm by 750 mm, 500 by 500 mm. So 3 different column sizes, just to simplify this project, demo project. We can also assign the crack section factor. On the screen, you can see the axial flexure. And for beam, I'm going to use the same beam size for the whole building. I'm going to use T-beam. (400 mm depth by 230 mm). Okay. And the program will automatically calculate the flange width depending on whether it is an internal beam or an exterior periphery beam. So T-beam as well as the L-beam property, the program will calculate it automatically. And now I'm going to assign the slab thickness. So you can see the deck slab property information. There are 3 tabs here: composite flow, which we are going to use it tomorrow. But today we are going to just use for concrete slab system. I'm going to use a 200 mm thick slab. And you can also specify the slab stiffness multipliers, crack factors, stiffness modifiers. And for mat foundation, I'm going to use a 750 millimeter thick mat foundation. Okay, so two different slabs I modeled just now. And the slab, I'm going to assign this 200 mm thick slab for the whole floor as a two-way slab for both typical and typical 1. Okay, for the whole floor, for roof also, 250 mm thickness. Okay, next I'm going to assign the column sizes. Previously we just created, and now I'm going to assign it. Okay, so I fast forward it. So we finished assigning the columns and beam sizes and slab sizes. And now we are filling up the story data. So here we specify the level 1 as ground level and specify the floor to floor height as 1.5 meter. That will be my plinth level. And then from second level to sixth level, I generate by using the typical floor layout. Okay. So this is how the program works. So you model the floor layout in grids and then use the story data information to specify the height, floor to floor height of different floor types. And then you hit the generate button. And the floor naming, you can prefix and suffix with the generation options here. And then hit the add button. Okay. So I'm going to now change the level to story so that it'll be easy to identify. Okay. Ground level, which is actually the plinth level, and then following from first story till sixth story. Okay, so I generated all these floors, ground level, first story, second story, up to fifth story, sorry. Okay, the floor to floor height for all the floors is 3 meters, except the plinth floor, which is 1.5 meters from the foundation level. And then I'm going to generate some more stories from sixth level, from 7th level to 11th level. The 11th level will be my 10th story. Okay. The reason why I'm generating using a different floor layout is because I'll be varying my column sizes starting from my 6th story onwards. Again, for roof, I'll be again modifying my reducing the column sizes. So that's how this story information helps a lot to assign the sizes. Now that we specify the story information, we can see the 10-story building. You can see there are some mistakes in the model. The roof layout, I forgot to assign the roof layout for the 10th story. I created it, but I forgot to assign. So now you see the level 11, that is 10th story. I changed the floor type from typical to roof. Okay, and I also forgot to assign different floor type for levels from story 6 onwards till 9th story. Okay, so that's typical 1. So it's so easy to modify the floor layout by just using the single story data dialog. Okay, now I did the modifications. Now we can see the 3D view of the building model. Now you can see the roof is correctly assigned. Few other things are missing, such as the foundation details and the shear wall opening for the lift core. So now I'm going to first show you how to assign the foundations. First, I'm going to assign spread footings for all the corner footings, isolated pad footing. Next, I'm going to assign pile cap for all the internal footings, internal foundations. And then I'm going to assign combined footing for my shear walls. And then mat foundation. See how easy I'm going to assign the mat foundation. I just specify the edge offset and click on the mat. You have to do it carefully here. Sometimes it's possible to make easy mistakes like clicking on the slab edges, slab opening edges instead of the shear wall edges. So you see the same mistake I did. So I'm going to delete and redo it. I zoom in for better visibility. And then I'm going to show you clicking on the shear wall edge instead of the slab opening edge. Okay, so then the mat foundation is ready. Okay, now I'm going to assign the properties for the mat. Remember, we also created a 750 mm slab, so I'm going to assign the mat foundation thickness. Okay. And next thing we need to do is the creation of the openings for the shear wall. So I select the elevation view and hit the Add Opening button. Compare this feature with StatPro, and then I hope you'll understand what I'm saying as a special purpose building analysis program. Imagine how difficult it is to create the openings in shear walls in StatPro. And see how easy I am going to create in RAM structural system. Not just creation of openings, but even copying and modifying the openings is so easy. And you are working on a physical model here. So now you created the opening, and now let's see the 3D model with all the modifications, including the foundations, including the shear wall openings. So I hope you see this maximum. It took 20 minutes with all the delay in the video sharing the screen. We finished the 10-story building modeling, and now I'm applying the gravity loads such as dead load, live load, and partition load, construction live load, mass dead load, etc. And note that the program will do the live load reduction automatically as per the code that we selected in our criteria. So now I'm assigning the load for the floor layouts. So for typical floor layout, I may have different loads. For roof, I may have different loads. But for this demo, I'm going to use the same load even for roof. So this way, we finished assigning the gravity loads. And note that you can also assign line load, point load, etc. in addition to surface loads. But for this demo, I'm going to use only the surface load. But if you have some overhead water tank, it's easy for you to assign the line load and point load. Okay. So now after doing all this thing, I'm checking my model by performing the integrity check. There's no errors. So now we can see I exit out of RAM model is showing as green color, meaning the model is complete without any errors. And now we need to do the lateral loading in RAM frame. Okay, so I open already completed model. There are a few other things that needs to be modified, such as the member releases. So I open a completed model with all the releases correctly assigned. Note that you don't have to do this for your project. Is just to demonstrate to you the capability of modifying the releases. I'm doing this. Otherwise, when you use the gravity member, automatically the program will assign the pin end connections. And when you model the gravity lateral members, all are continuous connections, rigid connections. And here's a physical model. And here's the load cases. So we can generate the wind loads, seismic loads, all the international codes, including all the editions of the ASC codes are available here, including Euro code, UBC code, Australian code, Chinese code, Indian code, including notional loads also. We can also generate user-defined story forces if the code that you're following is not implemented in RAM structural system. You can calculate the lateral force and apply it as a user-defined story forces. We can also create construction stage analysis, which I already did for this example. I created 11 stages just at a button click. The program will automatically assign, generate the stages. So 10-story building, including the plinth level, is actually 11 stages. This is stage 1, that is constructing the plinth level, then stage 2, 3, 4, 5, till stage 11. Okay, so the program will automatically create this stage construction analysis and store the results for different stages. Okay, so now we can generate the mesh for the model. The wind load I used is Eurocode, but you can use it use any other code. This is the typical dialog box for the wind load. You can just specify the basic wind speed and the directions and some of the fields that is required as per the code. For example, here I'm generating the seismic load, static seismic. So I specify the design ground accelerations and the directions. The program automatically generates the seismic loads. That's it. And now I rebuild the mesh data. Now the whole physical model is being meshed as finite elements. This is the beauty of RAM structural system. Modeling is so user-friendly. You model the slab as slab, wall as wall, and then click a button. It will convert into a finite element model. That's it. Now you can see the mesh. By default, we use 1.5 meter coarse mesh. The user can change the mesh size, but we have done several benchmarks, and we noticed that for global analysis, a coarse mesh size is good enough. The stitching between the meshes happens automatically in the program, so we don't need to do any modifications in the default mesh generation. And then we do the analysis, select all the lateral loads. The gravity loads are already brought from RAM modeler. And here we are doing the finite element analysis. It just took 2 minutes, 1 minute 45 seconds for completing the analysis. And after we do the analysis, we generate the load combinations. And now we can see the deflector shape for any load case, primary load case or load combinations. I reduce the scale factor to 100. So we enlarge it 100 times. So the deflection values you can see is 15 millimeter. And we can animate it. And we can view for other load combinations as well. So this is for dead load, live load, and wind load combination. We can also view the member end force diagram, shear force diagram, bending moment diagram, axial force diagram. But just to save time, I'm going to skip that. Now we move on to the concrete gravity analysis for analyzing our gravity members and also for load takedown for each floor due to gravity load. Okay, so after this analysis, we can see the gravity load takedown from top to bottom. Floor wise, we can check the reactions. Okay, so here you can see for this is ground floor. Sorry, I rewind it slightly. So here's the top floor. Okay, vertical reactions for dead load. This is a top floor vertical reaction. And here's the 9th story. Here's the 8th story. For dead load and gravity load, we can do the same check, how the load is distributed from top to bottom, the load path. As we move down, you can see the load intensity, the reactions increases. So we now finished all the modeling and analysis and load combinations in RAM structural system. Now we need to proceed with the design. So for design, we can either use RAM structural system or RCDC. For this project, I prefer using the RCDC because the design and detailing features of RCDC are better than RAM structural system. So I use RAM structural system only for modeling and lateral load analysis and gravity analysis. And for design, I'm going to use RCDC. Some of you are familiar with RCDC already. For those of you who are not familiar with RCDC, RCDC is part of StatPro Advanced. And now with the latest release of StatPro, the basic features of RCDC are even part of StatPro Basic version. So please make sure you update your StatPro to the latest version 22 Connect Edition, and then you see a third option to use StatPro Basic. Okay, but that you need to launch it from StatPro itself, not as a standalone RCDC. Okay. Okay, so now I'm closing the RAM structure system model, and I'm going to choose the code here. So I can choose the Euro code or American code or British code or Indian code. Okay, the latest version even have the ACI 2014 imperial units. The version which I'm showing now is recorded a few months before. So it was using the ACI metric 2014 metric code. Okay. So I'm going to choose the model which we just finished analyzing in RAM structural system. Takes a little bit time. Let me fast forward that. And then after the import is done, you choose the design element which you want to design. I'm choosing column and wall. And RCDC is now getting ready for the design of column and wall. It's reading all the analysis results, including the stage construction analysis results from RAM structure system. That includes the creep and shrinkage of concrete. Okay, so now we have the column and walls imported in RCDC from RAM structure system. And use the settings button to specify the design settings. You can perform the ductile design. And you can also design for crack width also, and specify the bar sizes that is available in your country, minimum and maximum bar sizes. You can choose from the rebar number or rebar diameter. So specify the settings and choose the design code and hit the auto design button. And now the program is performing the concrete design. And here's a spreadsheet showing you the results. On the left side, you can see all green color, meaning all the columns are passing. And instead of using this several rows of spreadsheet, I'm going now performing the group for the entire building. So all similar column sizes and similar reinforcements will be grouped, so that instead of having hundreds of rows, we are now having only lesser rows. Okay, so here you can see the columns and walls, main reinforcement and links on the right side, and the capacity ratios. And here we generated the text schedules. There are two types of text schedules. And here is the text schedule that shows the grouping of the column. This is a non-ductile text schedule. We can also produce a ductile text schedule as well for the column design. Okay, and a few more button clicks, you generate this detailed drawings for your column cross sections and shear walls. And a few more button click, you generate this column elevation detail drawing showing the laps. Few more button clicks, you generate the summary, design summary. Just a few pages for the summary, and then one more button click to show the design calculations. You can choose for the whole building or only for selected members for the calculation report. And here's the calculation design calculation report. Okay, showing you all the step-by-step calculations, including the formulas and codal references. Next is the bill of quantities. The program now knows the length and sizes of all the concrete members. So it should be able to calculate the quantity, the volume, and the cost. You can choose the currency. Note that the currencies are limited currencies are available now, but you don't need to worry. If your local currency is not available, you can choose any currency. but you can the local rates, you can put in the local rates, and then once you produce these reports, you can edit the currency symbol in your Excel or MS Word report. So this is the estimation we did it for a column that includes form work also. But if you do estimation for the foundations, that will include the excavation also. So within few minutes, we generated text schedule, detailed drawings, column elevation drawings, design summary, design calculations, bill of quantity in 3 different formats. Okay, we can save this as DXF files, or you can open it in Bentley MicroStation if you have MicroStation installed in your computer, or just save it as a DXF file and open it in any CAD software. So now we have finished the column design and wall design in RCDC. Same way we can design the beams, slabs, and foundations. Okay. So we finished step 5. Next is step 6, that is mat foundation design. So I'm going to use RAM concept for that. So from RAM structural system, we now select RAM concept, and then we can choose to design mat foundation or elevated slabs. RAM concept can do both. Note that both RCDC and RAM concept can design the slabs, but the difference between these 2 programs is RAM concept uses a finite element method, whereas RCDC uses the coefficient method as specified in the code. It uses the empirical formulas to design the slab. So depending on the complexity of the slab and depending on the span of the slab, you may either choose to use RCDC or RAM concept. But RCDC is limited to only one-way and two-way slabs, whereas concept can handle any type of slabs, including flat slabs and post-tension slabs. So this is the mat foundation which we imported from RAM structural system. Remember the lift core. The lift core is also imported. And here we specify the soil subgrade modulus. The program will generate the spring automatically. And here we do the mesh, just a crude mesh to start with. And then I generate the design spans and design strips to analyze my mat foundation in both the direction. I generate the design spans and design strips. So once we do this, we go back to the mesh and we regenerate the mesh. After the design spans and design strips are generated, you can see the mesh is very smooth now. And now all we need to do is run the analysis. The program will use the compression-only springs for this mat foundation and do this analysis, finite element analysis. For all the load cases and load combinations imported from RAM structural system. So there is a beauty of this interoperability between these 2 programs, so that we don't need to spend more time in recreating the mat foundation. It's all imported from RAM structural system. And finally, RAM concept says that the mat foundation is okay. But then we need to go and check the base pressure, the soil base pressure, and the reinforcement, etc. If the base pressure is exceeding the soil bearing capacity of the soil, then we need to increase the area of the mat foundation and reanalyze. So here you can see this is the soil base pressure. So the maximum value is 249 kilonewton per meter square. Definitely this will exceed the safe bearing capacity of the soil. So I need to increase the area of the mat foundation and redo the analysis until the maximum base pressure is less than the allowed value. And this is the deflection diagram. So we have 2.5 millimeter deflection, which is okay. And we can see the results for ultimate load cases as well as service load cases. We can now see the bending moment diagrams for our mat foundation. And we can cut a line from this contour to view the graphs. Okay, so those are the capabilities. Finally, we can see the reinforcement in 2D. And we can modify this reinforcement provided by the program. You can change the way it shows. You can modify the diameter of the bar and show it as user-provided reinforcement. Then the program will change the color from yellow color to orange color, explaining that yellow color is a program designed, orange color is the user modified. Usually what I do is I delete the reinforcement designed by the program And then I use this tools menu to provide my own reinforcement and use these calculation options to check capacity of user reinforcement without designing additional program reinforcement. So that way, I have total control on the reinforcement that is provided in the site. So it can be managed easily in the site. And finally, you can walk through the reinforcement. And estimation. So this estimation tool is a very useful tool for you to compare if you're designing a slab as a reinforced concrete slab or a post-tension slab. By designing the same slab as a post-tension slab, you may reduce the thickness of the slab, but the labor cost will be more. So the estimation page will help you to come to a conclusion to choose the scenario. Okay, so now that we finished designing this mat foundation as a reinforced mat foundation, and then we can save this detailing in a DWG file, and we can close RAM concept and come back to our RAM structural system. And with that, we have finished the mat foundation design. Okay, so with that, I'll stop the sharing of my screen. Okay, I'll proceed with the our slide now. Sorry, there is some. The latest features. Okay, sorry. So far, I hope everything is okay. Let me do a pulse check to check whether all of you are seeing the screen now. Please respond to the pulse check. Are you able to see the latest features slide? I switched from screen sharing to the on24 screen. Hope that is okay. Okay, thank you for responding. Okay, so the latest features in RAM structural system in RAM product is the implementation of tilt-up construction for RAM structural system. In some countries, this type of construction is gaining popularity. So we don't have time to look at this in this webinar. I would suggest you to see a YouTube video on this. Just search for tilt-up construction in RAM in YouTube, or just subscribe to our Bentley YouTube channel, and then you can see the video there. Okay. And then also the RAM concept post-tension optimization, which is a relatively new feature. Also, there's a YouTube video available here. I suggest you to watch this. These two are the very important new features. This optimization is possible by using the cloud computing feature in RAM concept. And the new features in STAAD Advanced Concrete Design RCDC is the implementation of the ACI Imperial codes. Previously, it was available for metric code, but now we have the Imperial also. And now we also have the ACI 224 or 01 crack with checkouts and a few other minor important features. Previously, when we use this RCDC along with StatPro, we need to model the shear wall as column in the StatPro model, but that limitation has been removed now. Now RCDC can import the shear walls modeled as surfaces in StatPro, either using the StatPro physical modeler or using the StatPro analytical modeler, using the parametric surface command in StatPro. Those are the improvements in the latest RCDC. Next, coming to the important topic, BIM interoperability. Okay. So I have a small video. Hope you're able to see the video. In this video, I'll show you how to interoperate with BIM softwares like Bentley's Open Building Designer. The same concept can be used for interoperating with Autodesk Revit as well. Hope you are able to see the video. This is a small video, so I'm sure you'll be able to see the video. So in RAM structural system, you can see I click on this file menu and use export ISM export. Okay, and this ISM has option to export even the RAM concept slab design. We use two programs, RAM structural system and RAM concept, to design this building. So ISM will take care of both. Note that this ISM is capable of even absorbing the reinforcement design, provided the reinforcements are designed using RAM structural system. But in this case, I have used RCDC, which is an external program to design the reinforcement for my columns. So the reinforcement is not exported. Okay. So now I'm opening Open Building Designer, Bentley's Open Building Designer, Bentley's BIM modeling program, multidiscipline BIM modeling program. So here I use this analysis menu and use new from ISM repository. And then a few settings. And hit the import button. The mapping is not needed because both these programs belong to Bentley. But if you use Autodesk Revit, you just need to spend a little bit time on the mapping. For concrete, there's not much of mapping required, whereas for steel, mapping is required. Okay. So you can see the columns, walls, slabs, all are imported, including the floors. So the complete model are getting imported from RAM structural system into Bentley's Open Building Designer, including the grids. Why do we need to do this? Once we have the structural model in a BIM program, we can reference this model with other disciplines such as architectural, mechanical, electrical, plumbing, etc. So that you can perform clash detections, quantity estimation. So here you can see I'm using the spreadsheet feature in the Open Building Designer, structural quantity report feature, to calculate the complete lengths and volumes and weight of all my concrete components, columns, beams, walls, slabs, foundations. The complete details are now available in spreadsheet. And just a button click, we can easily summarize automatically. So here you can see C750 by 750, the column. I have so many number of columns, and so 1 meter by 1 meter, I have so many, and 600 by 600, 500 by 500. So very easily we can summarize. And then we can use the drawing production tool in Open Building Designer to create any drawings that you want, cross-section drawing or elevation drawing. But this is not an Open Building Designer presentation. I just show you the import feature. Okay. So watch out for a seminar on Open Building Designer to know more about that program. So we come to the near end of this presentation. So let's summarize. Structural worksheet, enterprise worksheet contains all these 8 programs, and I have used RAM structural system and RAM concept and the RCDC feature of StatPro for completing this presentation. The big picture slide shows you the ISM interoperability between Bentley's structural programs on the left side, with the Bentley's BIM and detailing program on the right side, and also our partners Tekla and Revit on the bottom by using this ISM plugin. This ISM installation is free. You can just install a structural synchronizer. Most of the programs are Bentley programs. It installs it automatically when you install StatPro or RAM structural system. But for using it with Revit and Tekla, you just need to Google search ISM plugin for Revit or Tekla and download it for free and install it. Okay. So completing a concrete building design project requires several softwares varying from BIM modeling, structure analysis, design, detailing, bar bending schedule, quantity. I forgot to show the bar bending schedule in RCDC, but you can also do that in RCDC just because of the time restraint. The button click, you can generate the bob bending schedule for all the concrete components, even in spreadsheets as well as drawings. Bentley Structural Enterprise Worksheet gives a bundle license which helps complete the project with one license. The ISM technology helps in interoperability between the structural analysis and BIM program. So with the help of the above Bentley structural technologies for concrete buildings, we can finish our concrete building design project more efficiently and at an affordable software cost. So please subscribe to our YouTube channel. Search for Bentley Structure and subscribe. All the trainings for all our programs are available in LandServer on demand. So please utilize this for Bentley users. It's all free. You can also print our certificates after you complete the training. Support can be available through various channels, communities.bentley.com or service request manager, connect advisor, which opens up with the program. Okay, so we'll move on to the few final polls before we conclude our presentations, start the Q&A session. So please respond to this poll. Now that you have seen RAM structural system and RAM concept, do you plan to use it for your upcoming concrete building projects? So 10 more seconds for answering these polls. So please respond to this poll and submit. I'll give you 5 more seconds. Okay, thanks for participating in this poll. Next poll, would you like to participate in our Bentley Year in Infrastructure 2020 presentation in October involving ISM? If you have done any of your projects using Bentley structural programs involving ISM, if you would like to participate, it's a virtual event in October this year. If you would like to participate in the presentation, please say yes here so that we can contact you with more details. Okay, give you 5 more seconds for this. Okay, thank you for submitting the poll. And if you require any one of us, our sales team or technical team to contact you, please respond to this poll. I'll give you 5 more seconds for this. Okay, thank you. So with that, we'll move to the question and answer session. If any one of you have any questions, you can type in the Q&A at the bottom of your screen, Q&A box. I'll respond to it one by one. Okay, so there are nearly 30 questions posted. I'll go through it one by one, but if any one of you need to drop from the presentation, please feel free to do so. Sorry for the delay in the presentation. But please participate in the survey following this webinar. Okay, thank you. So I'll go from the first question. Can RAM structural system be used for high-rise commercial building with a combination of steel, concrete, composite, post-tension, mat foundation, post-tension floors, mat foundation, pile caps, combined foundation, isolated foundations? Yes, that is the strength of RAM structural system. It can be used with a combination of all this, yes. Okay. What is the major difference between StatPro and RAM structural system? The major difference is StatPro is a general purpose structural analysis program, whereas RAM structural system is a special purpose structural analysis program specifically made for buildings. Okay, so that is the difference. Moving on to the next question. Is it possible to model inclined columns and ramps in RAM structural system? Yes, that is very easy. Another question, what is it? Sorry. There are some questions about audio. Okay. Another question, my company used StatPro Basic. If that StatPro Basic support design and detailing of pre-stressed beam, if StatPro support the pre-stress feature, can you explain us a little bit general how to use this feature? Okay, see, StatPro does not design or detail pre-stress beam. We can apply only the loading, the pre-stress loading. For pre-stress beam design, RAM concept is the best software for you. There you can model the tendons and you can model the slab and beam, and there you can design the pre-stressed beam. Okay, so StatPro is not the right software. It's useful only for analysis of the pre-stressed beam, not for the design and detailing. Okay, another question from Romal. Does RCDC require a separate license? See, R-Series is available in 3 different flavors. It is now available in the StatPro Basic. So if you're already a StatPro user, just make sure you use the latest version of StatPro, version 22, Connect Edition version 22, update 4, that has the limited features of R-Series. So when I say limited features of R-Series, that includes the beam and column design only, and including, only beam and column design. For other advanced features such as slab design, foundation design, and producing detailed drawings, bar bending schedule, you need to upgrade your StatPro to StatPro Advanced, okay? And also to produce detailed drawings. With the basic R-Series, you can generate the detailed drawing still, but you can't able to save it or print it. Okay, so that is the limitation in the StatPro Basic. So there's 2 flavors, StatPro Basic and StatPro Advanced. And the third flavor is R-Series is also available as a standalone license. Okay, so these are the 3 ways you can license R-Series. So if you already have user of StatPro, you have it already, the limited version. If you already have StatPro Advanced, you have the full feature of R-Series already. Okay. Another question. Can I have the slide after the session? Yes, I can send you the PDF of the presentation. So please drop in your email in the Q&A session, the Q&A box. I can send you those who request a PDF. Okay. Another question is difference between R-Series EFE and RAM concept, since both of them using for slab mat foundation. Okay, good question. R-Series EFE and RAM concept. R-Series EFE is a standalone program. Even though it's a standalone program, the model has to be created and analyzed in StatPro first. So R-Series E has to be used along with StatPro. R-Series EFE does not have any modeling capabilities. It has only design and detailing capabilities. It doesn't even have analysis capabilities. It reads the analysis results of StatPro. Okay. Whereas RAM concept is a standalone program. You can start the modeling, you can apply the loads, you can perform the finite element analysis, you can proceed with design, detailing, estimation. Okay, so that is the difference between R-Series EFE and RAM concept. Both has the slab design as well as mat foundation design feature, but the difference lies in the way this program works. RAM concept is a complete program, whereas R-Series is a dependent program only on StatPro. RAM concept can import the results from StatPro, can import the geometry from StatPro, and can import the geometry plus analysis results from our RAM structural system. Okay, whereas R-Series EFE can import only from StatPro. So those are the differences between these 2 programs. Okay, hope I answered your question. Another question, how to avail webinar for tomorrow as mentioned. I believe Derek has already answered that. He has given you the link. Okay, ISM is short of, I understand this question. ISM means is integrated structural model. Okay, so that's the meaning of ISM. It's useful for exchanging the model from one software to the other. So the last part of my presentation, I showed you how easily I exchange the model from RAM structural system to a BIM program like Open Building Designer. Same with Revit. I could have done the reverse way. I could have done the modeling in Revit or Open Building Designer and then imported in RAM structural system. So both way is possible. Okay, another question. Why would you recommend RAM for designing of foundations? What are its advantages and disadvantages compared with using StatPro in the design of foundations, especially mat foundations? Okay, it's a good question again. It all depends on the project, what type of projects you do. For example, if your project is a multi-story building, then I would recommend to you to use RAM concept, because RAM concept can directly read the geometry of the mat foundation from RAM structural system and also the analysis results. Whereas if you use StatPro, you know, I believe you are relating to Stat Foundation Advanced. Stat Foundation also has the mat foundation design, but it cannot read the results and geometry from RAM structural system automatically. So you need to manually model the mat foundation in Stat Foundation Advanced. Okay. So I hope I answered your question. If your project is an industrial plan type of project, process plan, power plant type of projects, and those type of projects has to be modeled, analyzed in StatPro, the superstructure, and then you can use Stat Foundation Advanced to read the results to proceed with the Mat Foundation design using Stat Foundation Advanced. So it all depends on the type of projects. For buildings, I would recommend RAM. For non-buildings, I would recommend Stat. Hope I answered your question. So both the programs has advantages, but it depends on the project. Okay. RAM, another question. RAM structure system can be used to design and detailing pre-stressed beam. I think I already addressed that. To get the number of pre-stressed strand. No, StatPro is not the program. RAM structure system also is not the program. You need to use RAM concept for that. You need to specify the pre-stressed, the post-tension strands, and then analyze and design it and check whether it's passing. Okay. If not, you need to increase the strands. Another question, please show any small RAM concept flow and import that in RAM structural. As was mentioned in a case study slide for Australia. Oh, okay. Yes, definitely. See, I didn't cover that part in the presentation. One of the good workflow is that if your building project is a flat slab, then I mean, if a building has flat slabs, then I would recommend to start the modeling in RAM concept, the flat slab flow, and then save it as a ISM file, or directly import that, export that to RAM structural, and create the multi-story model. So that is a very good workflow that I have not shown in today's presentation. Of course, there are many workflows, but because of time limitations, we can't cover that many. But if you're already a user of RAM structure system and RAM concept, you can try it, or you can reach out to me if you need a separate demo. I can do that. It's a very good workflow for RAM concept and RAM structure system. And another question, please compare and suggest where to use RCD CFE or RAM concept or Mat Foundation or any other flow types, whether post-tensioning is better analyzed in either. No, RCD CFE cannot handle post-tension. It's only RAM concept that is good in post-tensioning. And I also explained in the previous question on the same topic, the differences between RCD CFE and RAM concept. RAM concept is a standalone program, whereas RCD CFE is dependent on the StatPro model. RCD CFE cannot be used with RAM structure system, whereas RAM concept can be used with RAM structure system as well as StatPro. Okay, hope I answered my question. Okay, some of you have faced some problem viewing the video. Please note that the recordings are available. So I will be available in another 1 hour or so. So you'll be getting an email that the recording is available, and then use the same link to join and view the recording. Okay, another question, can RCDC perform beam column joint checking? Yes, it is available in RCDC, the joint check, beam column joint check. Yes, it's a good question. Another question, what is available in Bentley for performing performance-based analysis and design? Right now, we do not have performance-based analysis and design, AAC as by AAC 41. We have the pushover analysis feature in StatPro Advanced. That is based on the FEMA code. It's not yet updated for AAC 41. So right now, we don't have this feature. Okay. Another question from, since beam design and column design is being done separately in RCDC, is it possible to import any beam design result to column design module? So column design will use it for joint shear calculation. Yes, that is possible in RCDC to do that. Okay. Another question, hope to see seismic analysis also. In fact, today's demo, I did show I did include the seismic analysis static method as well as response spectrum. We didn't go into detail because of time limitations. We need to cover so many other topics. So it's so easy to do the response spectra as well as static seismic in RAM structure system. Okay, I see that 30 more questions. Another question, code application in every country, does it include, or the software is flexible to all codes? Good question. When you buy RAM structural system or structural enterprise worksheet, all the design codes comes in. It includes the American, Euro code, Australian code, Indian code. So all the design codes are included in both StatPro as well as RAM structural system and RAM concept and RAM connection as well. including Stat Foundation Advanced as well. All the design codes are included. Is any of this compatible with ETABS? Only RCDC. When you buy RCDC as a standalone software that can import the ETABS analysis results and proceed with the beam, column, and slab and wall design and foundation design. Another question, how much is the price in US dollars for the whole package? Unfortunately, I can't answer that because the price varies from country to country. So you please keep in touch with our sales colleagues. So I see that you are from DPWH. So please keep in touch with our colleague Darius, who might have sent this invitation for this webinar. So you would be able to give you the quote. If not, the local channel partner. Okay. How will you model shear wall in StatPro and design it in RCDC? You can model the shear wall in StatPro using the StatPro physical modeler. There is a webinar I did beginning of this year. I think it's in March. It was the title of the webinar was StatPro physical modeler. I would suggest you to watch it. Just visit our Bentley website, bentley.com, and look for events. And in the events menu, you can see on-demand webinar. So already happened webinars, you can see the recording there. So look for this StatPro physical modeler webinar where I showed this shear wall modeling in StatPro and designing in RCDC. Okay. How do you model shear wall in StatPro and design it in RCDC? Yeah, you already answered it. Another question, how about pipeline system and supports for oil and gas or geothermal? What can you recommend? Pipelines. Okay, for pipelines, we have a pipe stress analysis program, Bentley AutoPipe. I just did a seminar on this beginning of this month. So please watch the recording of it in our Bentley website. Look for events and look for AutoPipe software. Pipe stress analysis. The topic which I presented beginning of this month was interoperability between piping and structure. So I would suggest you to watch my another webinar coming up next month, the first week of next month. Please look for invites in public media like LinkedIn or look in our Bentley website or contact our local sales team who will send you the invite. So there you can see the AutoPipe software. Okay. Pipeline system. Okay. Few of you are dropped in your emails for the PDF. Okay. Another question: how to link rebar from StatPro to Pro Structures? Unfortunately, right now the link between StatPro and Pro Structures through ISM can interoperate only the concrete sections. It can't interoperate the rebar. The rebar has to be modeled in Pro Structures. Okay. I hope that answers your question. Many emails. Many email address was requesting for PDFs. So the questions are reducing now. What is the best software for simple structure analysis of coal mining purposes? For mining structures, since it's a process plant, you'll be having process plant and mining plant. So StatPro would be the best software for that, simple structure analysis. Okay. Another question, if you want to design and analyze mat foundation, that data not come from StatPro, we can use RAM concept. Is it? Yes, you are correct. If the mat foundation is not modeled in StatPro, then you need to use RAM concept to model and analyze the mat foundation. Okay. You can also have another choice, Stat Foundation Advanced. Both the program can be used as a standalone program, not StatPro, Stat Foundation Advanced, which is another program. Okay. Stat Foundation Advanced and RAM concept can help you to model the mat from the scratch, apply the loads, and perform the design and detailing. Okay. So both the programs are good. If you have a PT transfer plate in building, what is your recommendation for utilization of RAM structure and RAM concept? In fact, these two combination, RAM structural system and RAM concept, is a very good combination to handle any type of buildings, including the post-tension transfer plate, transfer floor in the building. Okay, so use RAM structural system and RAM concept. You model the complete building, including the transfer floors in RAM structural system. After you finish the lateral load analysis, you export the slab in RAM concept. In today's workflow, I showed you how to export a mat foundation. Exactly the same workflow. Instead of mat foundation, you choose the elevated slab on the upper floor, the transfer plate. And then after you export it into RAM concept, you then model your tendons, okay, the post-tension tendons. And then if you want to even optimize those tendons, RAM concept now has the optimization feature using cloud computing. So after you optimize the tendons, and then you come back with the RAM structural system to import the updated column forces due to this post tension in the transfer plate, and then reanalyze your RAM structural system with the updated column force coming in from RAM concept due to post tension. So that is the best workflow, I would say. Two-way interoperability between RAM structural system and RAM concept. It's an excellent workflow for your scenario. Okay, another question is StatPro V8i SS6 same for StatPro RCDC V8i. RCDC is now part of StatPro Connect Edition version 22. If you're using StatPro V8i SS6, please uninstall it, upgrade your StatPro to StatPro Connect Edition version 22, update 4, that has the RCDC limited version for free. Okay, I hope that answers your question. StatPro V8i SS6 is at least 6 years old, 5 to 6 years old. It's outdated. Okay, so please don't use it. We are going to discontinue the V8i versions of all our software, not just StatPro, by end of this year. Okay, so please upgrade your StatPro to Connect Edition, StatPro Connect Edition version 22, update 4. That will have the RCDC free version. Okay. Hope that answers your question. Another question, can RAM structure system model and design flows that comprise the flat slab with drop panels at the columns? Yes, definitely. In fact, if you have seen my presentation, the beginning of the presentation, I showed you a simple 4-story building that the second floor was actually having the flat slab with drop panels. So that can be modeled in RAM structure system itself and also RAM concept. Okay, many of you are requesting for the PDFs. Yes, I'll send it to you later. Last question for today. Is it possible to link or open models in other softwares like eTabs or RAM or CDC and vice versa? Okay, so right now, only RCDC is capable of importing the eTabs analysis results. Otherwise, we don't have ISM plugin enabled in eTabs, so we can't exchange the model from RAM to eTabs. You may have to try with other neutral file formats like CIS2 to try, but I can't confirm the results. Okay. Hope with that we can conclude our today's presentation. Hope this was useful for you. For those of you who still have questions, can still continue posting it. I can respond to you by email. So thank you for joining us in this Q&A session. Okay. So please note down my email address in case if you want to contact me. For those of you who requested for the PDFs, I'll do send to you via email later. Thank you very much once again. And see you again tomorrow for steel building analysis, design, and detailing.